So we'll have time in class here to work on our review packets, our problem sets, start making our note sheet for the test, all that jazz. Before I release you guys to just work on your stuff, though, let's talk a little bit about the test format and kind of what to expect. So the test is 9 total questions. So you'll have to be able to list all the possible rational zeros for a function. How do you do that? It's plus or minus the factors of the constant term divided by the factors of the leading coefficient. If you didn't remember that, that would be a good thing to go onto your note sheet, right? You have to indicate the total number of zeros for a function. How do you do that? It's the degree. Exactly right. Good job, Ryan. So again, if you didn't remember that, I would put that on my note sheet. You'll have to be able to use limit notation to describe the end behavior for a function. So again, if you don't remember how to formulate your limit notation for an end behavior, put it on your note sheet, right? So if my function is f of x and the arrow on the right is pointing down, how do I write that end behavior using a limit? If the arrow on the right is pointing down, how do we write that? So you do limit x approaches f of x equals, and then something is going to go here and something needs to go there, right? Because it's a right arrow, x is approaching positive infinity, very good. And because the arrow is pointing down, it equals negative infinity. So again, if you don't remember that, or you don't think you can remember that, that's a good one to go on the equation sheet. You'll need to be able to use your calculator to find the extrema for a function. You remember how to do that? Just graph it and use the second trace max and min commands, right? Not a big deal. You'll have to be able to use your calculator to give all the real zeros for a function. How do you do that? Graph it on your calculator. You do second trace and use the 0 command. The zeros are the same as what part on the graph? The x-intercepts. Yep, exactly right. Good job. So again, those two should be pretty easy, right? You're just doing stuff on your calculator. If you got that stuff wrong on the quiz, though, you'll want to make sure to refresh your memory on how to do that, or if you need to write the steps, the calculator steps down, put them on your note card, right? If you're given a function and an interval, you'll need to determine if all the real zeros lie on that interval, and you'll have to be able to do that algebraically. How do I do that? To show that all the real zeros lie on some interval. That was a theorem we did in section 3. Let's see, where is that? Right here. So you check the upper bound of the interval. If you do synthetic division and all the bottom line is non-negative, then it's an upper bound, and then you check the lower end of your interval. You do the synthetic division with that number, and if the bottom line of the synthetic division is alternating from non-negative to non-positive, then that's a lower bound. So if the interval gives you an upper bound and lower bound, then all your answers are in between. So if you didn't remember how to do that or what those rules were, those rules I would definitely want to put on my note card because it's very easy to mix those up. And if you don't remember exactly how to do that, like an example like 13 here would be a good one to have. And this is, what is this, page 10 of the lessons, if you're looking at. the next one, it says you'll have to be able to write the lowest degree for a polynomial function possible with real coefficients in standard form, given some zeros and a leading coefficient. Well, what the heck does that mean? That's basically the same as like these problems 44 to 47, right? So if you didn't remember how to do those, that would be a good thing to kind of grab an example of and put on your note card. And the last one, there's two questions here like this. We're asking you to find all the zeros for a function and support your answer algebraically. Again, what's that going to mean? Well, it's like one of these problems 48 through 53. Sure. Is there one in particular you want to do? Maybe just not the first one. Okay. Well, let's pick an even one, right? That helps everybody out a little bit. You know what I mean, guys? No, that's not what I wanted it to look like. Try that one more time. So which one of the evens do you want to do? 50 or 52? 52. Great. All right. So what do I start with? Well, I know the fundamental theorem of algebra tells me I'm looking for 3 solutions because the degree is 3. I know from the rational roots theorem that my possible rational zeros are going to be the factors of 35 divided by the factors of 1. So the factors of 35 are 1, 5, 7, and 35. And if I divide all of those by 1, they're just same thing. So I'm not going to write over 1. Is that okay? Okay, so I have 8 of these then to check. Well, I don't want to have to just guess and check them. I can do something better than that. So I'm just going to go ahead and take a look at the graph for this and see what the x-intercepts appear to be, and see if any of those look promising. So it looks like there's one x-intercept, and that appears to be negative 1, 2, 3, 4, negative 5. Everybody's okay with that? Is that a reasonable answer to do synthetic division with? You betcha, because it's also on my rational roots list. If it wasn't on that list, I would not want to try it doing synthetic division with it. But it is, so I will. So I'll do my synthetic division. I got remainder 0, which is what I was hoping for. So what this tells me is that that this polynomial factors to x plus 5, because that gave me a remainder 0, times x squared minus 4x plus 7. So far, so good. Now, this all has to equal 0 if I'm looking for zeros. That's great, because if I apply the zero product property, each of these two is solvable because I have a linear equation. That was easy. And then I have this quadratic equation. Now, to solve this quadratic equation, what am I going to use? Can I factor this? Are there two numbers that multiply to give me 7 and add to give me negative 4? So what do I have to do if I can't factor it? Quadratic formula, yes sir. Now if you don't remember that, that would be something that I would write down on my equation sheet, because you'll need to use that. And it should be something that all of us have memorized, but if you're bad at memorizing stuff, I get it. It's not my favorite either. See, 4 squared is 16, and 4 times 7 is 28. 16 minus 28 is negative 12. Okay, so if I square root a negative, what am I going to get? An I, right? And then how do I simplify the square root of 12? I think about 12 as 4 times 3, and the square root of 4 is 2. So I have 2i root 3 all over 2. And now I can reduce that because I notice that each of these is divisible by 2. And so those are my 3 solutions, right? 1, and then this is 2 and 3 because I have 2 plus I root 3 as one solution, and then 2 minus I root 3 as the other. Does that feel okay? Yes. Yeah, you have 2 like that. All right. Anyone else have a pre-calc related question for me? Test format feel okay? Clear what you need to do? If you decide you're not, you can always come back up and ask me. Totally fine. Clear as to like what Mr. Kulik thinks should be on your note card? I tried to kind of talk that through as we went through the types of problems, right? If you want to talk about that more, that's fine. You can come up and talk to me about that if you're not sure. Anybody else with questions on things? Okay. I'm going to stop then and let you guys continue working.